Long time no see, friends! It's me again, your fellow mathster, Margaret Jude Broyo. Come along with me as we dive into this captivating realm of numbers, formulas, and more. For today's math blog, we will cover 2 lessons, illustrating polynomial equations and finding the roots of a polynomial equation. Does that ring a bell? Of course, since polynomial equations were already introduced from the previous grade levels. Buckle up, mathsters, for we will begin our journey to the first lesson of illustrating polynomial equations. The module that we have used for this lesson is from the Department of Education, Cordillera Administrative Region. In our previous math blog, we learned how to prove the remainder and factor theorem with Nicole. Today, we will identify if an expression is a polynomial or not, classify the degree of any given polynomial, and differentiate an expression from an equation. Let us start with a simple exercise. Put a check mark on the square before an expression if it is a polynomial, and put an X mark if it is not. For another activity, write the degree of the following polynomial equations. For the last activity, try to think of at least 3 examples of an expression and an equation. Great job for making it, mathsters! These concepts will help you understand polynomial equations. Now, if a polynomial is an algebraic expression involving only non-negative integer powers of one or more variables and containing no variable in the denominator, and an algebraic equation is a mathematical statement stating that 2 algebraic expressions are equal, then what do you think is the definition of a polynomial equation? How about if a polynomial can be classified according to the degree of the term in the polynomial? Do you think we can also classify a polynomial equation according to the degree of the polynomial involved? If yes, then how? Do you have any ideas? Let us try to verify those answers. A polynomial of degree n and x is an algebraic expression consisting of terms with non-negative powers of x. The n in its general form is a non-negative integer. The coefficients a sub n minus 1, a sub n minus 2, a sub 2, a sub 1, and a sub 0 are constants, and x is a variable. An algebraic equation is a mathematical statement stating that 2 algebraic expressions are equal. Therefore, we can define the polynomial equation of a degree n and x as a mathematical statement consisting of terms and non-negative powers of x. The following is a general form. N is a non-negative integer, and the coefficients a sub n minus 1, a sub n minus 2, a sub 2, a sub 1, a sub 0 are real numbers, and a sub n must not be equal to 0 and x is a variable. To further illustrate, observe the following examples. Aside from knowing how to identify if an equation is a polynomial equation or not, we can also classify its degree. The degree of a polynomial equation is the same as the degree of the term with the highest degree in the polynomial. Here are some examples. Try to check your answers on our previous exercises. Do you think you understand polynomial equations now? If you think you're already set to dive into the next lesson, then we can now proceed. If a polynomial equation has integer coefficients, then every rational root of the polynomial equation has the form p over q, where p and q has no common factors other than 1, and where p is an integer factor of the constant term. A sub 0 and q is an integer factor of the leading coefficient, a sub n. Let us use these theorems in solving the roots of a polynomial equation. In this example, we have x cubed plus 2x squared minus 5x minus 6 equals 0. Let us answer this step by step. First, list the factors of the constant term a sub 0 equals negative 6. This means that b is equal to positive negative 1, positive negative 2, positive negative 3, positive negative 6. List the factors of the leading coefficient a sub 0 equals 1. Q is then equal to positive negative 1. List possible rational roots p over q, and you get positive negative 1, positive negative 2, positive negative 3, positive negative 6 over positive negative 1. By observing the list, we can conclude that the possible rational roots are positive negative 1, positive negative 2, positive negative 3, positive negative 6. Second, we are going to look for a zero remainder. Using these possible roots, we are to divide the polynomial through synthetic division. Let us start with positive 1. Since the remainder is not 0, we will try another value. Let us have negative 1. Since the polynomial is 0, then x plus 1 is a factor of the polynomial. Great! Since the quotient is a quadratic, then we can easily find the other factors. Therefore, the polynomial equation in factored form is given by x plus 1, x plus 3, x minus 2 equals 0. Third, list down the roots of the polynomial equation. To solve for the roots, apply the zero product property. Equate each factor to 0 and solve for x. With these, we can conclude that the roots of the polynomial equation x cubed plus 2x squared minus 5x minus 6 equals 0 are 1, 3, and 2. Now, it's your turn. Using what you have learned in the recent discussion, try to find the roots of 2x cubed minus 12x squared plus 22x minus 12 equals 0. Follow the steps presented before.
Well done, Mathsters! You made it! I hope you had fun learning grade 10 mathematical concepts and honing problem-solving skills with me. Once again, I am Margaret Jude Roya, your fellow Mathster. For more educational content, don't forget to like, share, and subscribe to our YouTube channel. Until next time, goodbye!